Alrighty, welcome to part 2 of our semester review for pre-calculus. We're going to go through and take a look at the next 14 questions, which takes us through 29. So 15 says convert each angle from degrees to radians. Remember that if we're converting from degrees to radians, we're using some stoichiometry. We need to cancel out the degrees, so I'm going to put 180 degrees on the bottom. The thing is, I know that 180 degrees is equal to 1 pi radians. So I'm going to take this and simplify what I can. 225 and 180 are both divisible by, I think, they definitely are divisible by 15. That's 15. Oh, they're more than that. They're divisible by 45, I think. 225 divided by 45 is 5. 180 divided by 45 is 4. 225 divided by 45 is 5. 180 divided by 45 is 4, so it is 5 pi over 4 radians. For part B, it says negative 49 times pi divided by 180. Well, 49 is only divisible by 7. 180 is not divisible by 7, so because of that, that is the simplest it will go. And we'll just leave it like that. For C, we got 655 pi over 180. I mean, I definitely know those are divisible by 5, so 655 divided by 5 is 131. 180 divided by 5 is 36. I don't think 131 is not divisible by 3. I think that's it. So 131 pi over 36. That would be the simplest we can get that. And last but not least, again, we take the top number, negative 15, multiplied by pi, divided by 180. Well, we know that 180 is divisible by 15. We talked about this earlier. It's 12. So negative 15 divided by 15 is negative 1. So I've got negative pi. And then 180 divided by 15 is 12. So I've got negative pi over 12 as my solution. 16 is doing the exact opposite. Now they want us to convert from radians to degrees. So now what we're going to do, multiply by 180 on the top and then divide by pi. So what happens is the pi values cancel, and we just multiply the top numbers together and then divide by the bottom number. So in this case, I have 180 times 5, and then divide it by 6, and I get 150 degrees. Here again, we put our pi on the bottom and put 180 on top. Cancel, cancel, so 13 times 180, and then divide it by 4, and I get 585 degrees. Put pi on the bottom, put 180 on top, cancel the pi's. 5 times 180, and then divided by 3 is 300 degrees. And last but certainly not least here, we're going to put pi on the bottom, 180 on top. The pi's cancel. This one's got a negative in front, so I know my answer will be negative. 7 times 180 is 1260, divided by 2 is 630, so negative 630 degrees is my solution. For part 17, it asked me to come up with one positive and one negative coterminal angle for each. Now, there are lots of answers you could get here. There are a variety of answers. For this one, what I did is just added and subtracted 360, right? If I add 360 to 150, that's going to give me a positive coterminal angle. So 150 plus 360 is 510 degrees. In order to get a negative one, I'm going to subtract 360. So 150 minus 360. And that gives me negative 210 degrees. For this one here, part B starts with negative 740. When I add 360 to it, I get negative 380 degrees. So that's a good negative answer. Well, I go to add 360 again because it's still too negative, and I get negative 20. Well, negative 20 is going to give us another negative answer. So you could put negative 20 for your negative answer if you wanted to, but they said I need a negative and a positive. So I'm going to add 360 a third time. And in this case, I get 340 degrees. So those would be two coterminal angles that are positive and negative. Again, there's a ton of answers here. You could put an infinite number of answers. So whatever you got, as long as it was by adding or subtracting 360, that's an acceptable answer. Now I'm switching to radians. Remember that with switching to radians, you're doing 2 pi instead. 360 degrees is 2 pi. So I'm going to add and subtract, well, it's over 7, In order to make 2 pi over 7, it would be 14 pi. Because 14 divided by 7 is 2, so 14 pi divided by 7 is 2 pi. So I'm going to take 3 pi and add 14 pi to it, and I will get 17 pi over 7. And to do my negative, I'm going to take 3 pi and subtract 14, and I'm going to get negative 11 pi over 7. So my denominator stays the same. I just add 14 to the 3 pi and subtract 14 from the 3 pi. And in my last case, it looks like I'm going to have to add, well, it's over fourths, so it's going to be 8 pi over 4. It's already really negative. If I add 8 pi over 4, I get negative 11 pi over 4. If I add 8 pi again, I'm going to get negative 3 pi over 4. I'm still negative, and it needed to be a positive one. So I have to add one more time, and it looks like I'm going to get 5 pi over 4 as my other positive if I keep adding 8 pi to the numerator. Number 18 says a circle has a radius of 3 feet and a central angle of 137 degrees. Find the arc length subtended by the given angle. Remember the way we determine arc length is an S. S equals theta times r. Theta is the central angle, but it has to be in radians. And r is the radius as is. So I need to convert 137 into radians. So 137 times pi over 180. So I'm going to put that in my calculator. 137 times pi divided by 180. And I get approximately 2.3910. So I know theta is 2.391. I'm not going to take that out of my calculator because I want to keep that whole decimal, but that's what it's going to be. Times the radius, which is 3. So I'm just going to take this number in my calculator, multiply it by 3, and it looks like the arc length is going to be 7.17 feet. Part B says to find the area of the same sector. So the area is found by doing 1/2 theta r squared. So I'm still going to do the same thing to theta. I'm still going to take this 2.39 that I found earlier. So 1/2 times 2.39 times r squared. So times 3 squared, which is just 9. So I'm going to take this, let me find it again, 137 times pi divided by 180. So there's my 2.391. Times that by 3 squared, which is 9, and then times that by 1/2, which is the same as dividing by 2, and I get 10.759, so 10.76. 10.76 feet squared. That is going to be the area of the sector. 19 asks us to go backwards. It says, find the central angle that would generate a length of 78 meters on a circle with a radius of 6 meters. So I've got the length of the sector is times theta r. We know the sector length, or the arc length, is 78, so that's going to be 78. I don't know theta. I want to find it. And the radius is 6. Well, in order to solve this backwards, we'll divide both sides by 6. That will cancel. And 78 divided by 6 is going to give us 13. So I know that theta is 13 radians. For number 20, it says, find the following values rounded to the nearest thousandths. So we're going to need our calculator to do this. Well, there is no button in my calculator to do secant. So what I need to do is I need to put that in my calculator. First, what I need to do is I need to change my calculator. Currently, mine's in radians. So I'm going to go mode, go down here, switch it to degrees. Now I'm in degrees. So I need to find the secant of 59. Well, I know that secant is the same thing as the reciprocal of cosine, right? We know that secant is cosine's reciprocal. So what I need to put in my calculator is 1 divided by the cosine of 59. Or you can use a reciprocal button if you want to, which is, I don't know on mine off the top of my head. It's easier on the scientific calculator. They have those buttons on the scientific calculator, a little bit more obvious. So it's just going to be easier to put it in like that. 1 divided by the cosine of 59. and I get 1.941. It says round to the nearest thousandths. Thousand has 3 zeros, so I need 3 places. 1, 2, 3. So the 1 comes before a 6, so it's going to round up. So 1.942. Tangent of 22 pi over 9. So that's in radians, so I need to switch my calculator back into radians. Tangent's a little bit easier. We just do tangent, and then it's 22 pi, my pi button, over 9 equals thousandths place, so the 1 is next to a 2, so it's not going to round up, so I have 5.671. 21 talks about us graphing an equation of a cosine function. So it says find the amplitude. Remember, the amplitude comes from what's in front of the trig function, so amplitude equals 5. The negative tells us it's going to go opposite, but that's not included in the amplitude, so don't worry about putting the negative with it. Our period is found by taking 2 pi and dividing by b, which is the value in front of the parentheses. Well, this isn't actually simplified, so let's simplify it. I need to factor this out. So what goes into 6x and 30 pi? It's going to be a 6. 6x divided by 6 is x. 30 pi divided by 6 is plus 5 pi plus 7. So it looks like my 6 is going to be b. That helps me determine my period. So 2 pi over 6 simplifies to pi over 3, and that will be my period. The phase shift is the left or right movement inside the parentheses. Once we factor that out, it's really easy. Going positive 5 pi means do the opposite. Go left 5 pi units. If you don't factor out that 6, you'll get it wrong, so make sure you do that factoring step. And last, the vertical shift of whatever it's at the end, it's plus 7, so that means go up 7 units. Done. All right, going on to our next page, 22. This is all supposed to be done with no calculator, so be mindful of that as you're working through it. It does say no calculator, so do this without using your calculator now. It says take f of x and set it equal to g of x and figure out what values of x work. So I have x squared minus 3 equals 2x plus 5. So I need to combine my like terms, which there really isn't a lot of like terms, just the 5 and the 3. So I'm going to subtract 2x. I get x squared minus 2x minus 3, and I'm going to subtract 5, so minus 8 equals, and now I have nothing left over here, so it's 0. So I moved all my terms to the left, which means all I need to do now is factor that. What two things would multiply to make negative 8 but add up to make negative 2? Sounds like I'm going to have negative 4 and positive 2. Which means x is equal to negative 2 and a positive 4 when I set those each equal to 0. 23 says, what's the domain of f of x? This one's a little bit more challenging because not only is it a fraction, but there's also a square root in there. Let's start with the fraction part. Remember the denominator, this x squared, that's not allowed to equal 0. Well, that's pretty easy to solve. The only way to get x squared equals 0 is to be 0. So x can't equal 0. The numerator has a square root, and we know that square roots can't be negative. They can be any value greater than 0 or equal to 0. It's allowed to be 0. So I'm going to say 2x plus 9 has to be greater than or equal to 0. So we subtract 9 from both sides. I get 2x is greater than or equal to negative 9. Divide both sides by 2, and I get x is greater than or equal to negative 9 halves. From there, I can determine my domain. Does x being greater than or equal to negative 9 halves include that x can't be 0? And it does not, because 0 is greater than negative 9 halves. So I have to make sure that I account for that when I set up my answer. I know that it can be negative 9 halves and anything bigger than that. So normally I just put until infinity, but I need to restrict out the 0. So from negative 9 halves to 0, we're great. It's all good. But I need to skip 0, because that would put a 0 in the denominator, and go to infinity from there. So my domain is negative 9 halves to 0, skip 0, and go 0 to infinity. 24 has some functions that we're going to go ahead and add together and subtract and multiply. This is pretty easy. says take f plus g. So I'm going to take equation f and equation g and add them together. 3 and negative 8x is negative 5x. Negative 7 plus negative 9 is negative 16. And that's f plus g of x. F minus g means we got to do some subtraction. So f minus g. So 3x minus negative 8 is 3x plus 8, so 11x. Negative 7 minus negative 9, so negative 7 plus 9 is plus 2. And then they're going to have us do it the other way, g minus f of x. So negative 8x minus 3x is negative 11x. Negative 9 minus negative 7, or negative 9 plus 7, is negative 2. They end up being the exact opposites of each other. And part D says to multiply the two together, f multiplied by g of x. Don't rush through this and forget that you have to FOIL. You have to get every part multiplied together, not just the first and the last. So 3x times negative 8x is negative 24x. 3x times negative 9 is going to be negative 27x. That was 24x squared, sorry. And then negative 7 times negative 8 is going to be 7, 14, 20, 56 plus 56x. And negative 7 times negative 9 is going to be plus 63. So just combining these two middle terms in the middle, negative 24x squared. Negative 27 and positive 56 is going to give me positive 27x. That's not right. That's not right. Hold on. 37. 20 is going to get me to 36. Subtract 7 more is 29. So positive 29x, I'm sorry. And then plus 63. And 25 and 26. 25 says, given that f of x is equal to 3x plus 5 and g of x is equal to x squared plus 2x plus 1, find f of g of x. Remember what that means is plug x into g, which they already did, and then plug g into f. So I'm going to take this equation f, 3x plus 5, but where the x is, I'm going to plug in g. So x squared plus 2x plus 1, so that's 3x, and then plus 5 at the end. So 3x plus 5, replace the x with g of x. So we'll distribute that in, 3x squared plus 6x plus 3 plus 5. The only thing we have left to do is combine those two terms, 3x squared plus 6x plus 8. And that is our composition. This one says take f of x 2 over x plus 3 and g of x 1 over x, and then find f of g of x. So again, x into g is 1 over x, and then g into f. So 2 over, where this x is, I'm going to put 1 over x instead, plus 3. Well, in order to do this, we're going to need to simplify this bottom fraction into one fraction. I'm going to need to change that. So it looks like to do that, I've got 1 over x plus, well, if I want this over x, it was over 1. So 1 times x is just x. So we got 3x, right? The x's would cancel and it'd go back to a 3. So this becomes 2 over 1 plus 3x over x. And since I've got a number divided by a fraction, or we can make it a fraction divided by a fraction, we multiply by the reciprocal of the denominator. So 2 over 1 is the numerator, multiplied by the reciprocal of the denominator, x over 1 plus 3x, and I get 2x over 1 plus 3x as my composition, or 3x plus 1, whatever way you want to write it. Number 27, find f, given that the inverse function of the inverse function is the square root of 2/5 x. So remember, the way that we find inverses is that we switch x and y. Well, the inverse is the inverse of the original function. So to go back to the original f of x function, we just find the inverse of the inverse. So to do that, we switch x and y. So I make f of x inverse x, and I make this x a y. And now I need to solve for y. So to do that, I'm going to square both sides. So I get x squared equals, this cancels and this cancels, 2/5 y. And then I'm going to have to multiply by the reciprocal of this fraction. So it's going to be times 5/2. That would cancel that. 5/2. So I get 5/2 x squared equals y. So f of x equals 5/2 x squared. (28) says, given that f of x equals this, what is f inverse of 8? So what we need to do then is figure out what the inverse is and then plug 8 in. So again, to find the inverse, we make f of x equal x, and we make this side, we change the x into a y, so 7y plus 29, and we solve for our y. So I'll square both sides. X squared, the squaring both sides over here cancels out the square root. I get 7y plus 29. Subtract 29 to this side, I get x squared minus 29 equals 7y, and then divide by 7. So I can see that f inverse is x squared minus 29 over 7. From there, I can plug 8 in. So if I plug 8 in here, I can figure out what this is going to be. So 8 squared is 64. 64 minus 29 is going to be 54. 44 minus 9, 35. And 35 divided by 7 is 5. So if I plug in 8, I get 5. All right, next thing on here, or the last one we're going to look at today, is find all the zeros for the equation 16x squared plus 81. Well, what I notice immediately is those are both perfect squares, but they're not a difference of two squares, it's the sum of two squares. And remember what we talked about is that the sum of two squares creates imaginary roots. We solve it the same way that we would do our perfect, our difference of two squares. So I'm going to make two sets of parentheses. Square root 16x squared. So I get 4x and 4x. One gets a plus, one gets a minus. But if I take the square root of 81, the only way I'm going to get that to go back to a positive is that they have to be imaginary. So the square root of 81 is 9, so I'm going to have 9i and 9i. Remember, the reason this works is 9 times negative 9 is negative 81. I times I is I squared, which is negative 1. So that's negative 81 and negative 1. Negative 81 times negative 1 is positive 81. So I can see that my zeros are going to be negative 9i divided by 4 and positive 9i divided by 4. And that will bring us to the end of our second section. Good luck. Let me know if you need any help. Thank you for watching.